Okay, so can you see this?
Yes, sir.
Okay, so जो पहले का था classes inequality will not repeat that. We'll use that as a starting point. So first law says that du is equal to dq minus w or q minus w, whatever you write, it doesn't matter. From there we can get dq is equal to du plus dw. Cauchy's inequality says ds is greater than or equal to dq by t. That also comes from second law. And from here we get tds is greater than dq, greater than or equal to dq. So if you substitute in the first equation, what you'll get is tds is greater than or equal to du plus dw. Or if you take it on the other side, du is less than or equal to tds minus dw. And we consider only expansion work. So dw is equal to pdv. So therefore du is less than or equal to tds minus pdv. So equation 10 is a combined statement of first and second law of thermodynamics. किसी कोई doubt है इस पर? Any questions on this? Because you're going to use this as a basis for deriving criteria of equilibrium.
No, sir.
Okay. So can I move forward?
Yes, sir.
Okay. So equation 10 used for deriving criteria of equilibrium. So we consider systems of different properties. First, we consider constant u and v. We'll define different systems and then we'll see what are the criteria for different kinds of systems. Okay. So if the constant u and v है, तो du is equal to t less than or equal to tds minus pdv. ये हमने derive किया equation 10 above. And for an isolated system which does not exchange mass, heat or work with surroundings, that means there is no interaction with the surroundings, dq is equal to 0 and dw is also equal to 0. Our systems, chemical systems, are normally isolated. There is no interaction between the system and the surroundings. ठीक है, थोड़ा heat loss होगा, insulation perfect नहीं रहता है, but that is we have to consider later. For ideal systems, we will consider dq is equal to 0. Okay, and from this first law, d equal to dq minus dw, because dq is equal to 0 and dw is also equal to 0. So we will get du equal to 0. Okay. And well insulated vessel at constant volume would approximate this behavior. थर्मोस लिया हमने, अगर उसमें इंसुलेशन बहुत अच्छा है तो डेट विल अप्रॉक्सीमेट दिस बिहेवियर, बिकॉज वॉल्यूम भी कांस्टेंट रहता है और आइडियल रहेगा, अच्छा रहेगा थर्मोस, तो हीट लॉस भी नहीं होना चाहिए. तो कंबाइंड स्टेटमेंट लिखा हमने, इफ यू टेक du is less than or equal to tds minus pdv and put du equal to 0 and dv also equal to 0, because we are saying constant u and constant v system, constant volume and constant internal energy system. So what you'll get is, if you substitute in this equation, what you'll get is, this is 0, this is 0. So what you'll get is ds, this term remains. So ds for constant internal energy and constant volume system is greater than or equal to 0. Any questions on equation 11? Shubham, Das and Vaibhav, do you have any question? Hand raise किया आप लोगों ने?
सिर पहले ही किया था.
तो चेंज कर दो ना फिर, ठीक है? So any question on equation 11?
सर विजिबल नहीं है.
TQ0.
हाँ, क्या बोल रहे हैं? विजिबल नहीं है? नहीं दिख रहा है?
T0 क्यों होगा?
क्या जीरो होगा?
T0 होगा ना?
टी जीरो नहीं है, टी इज नॉट जीरो। डी यू इज इक्वल टू जीरो एंड डी वी इज इक्वल टू जीरो, राइट? ये हमने बताया अभी, कांस्टेंट यू एंड कांस्टेंट वी सिस्टम में क्या होता है, राइट? तो देन टी डी एस इज ग्रेटर देन और इक्वल टू जीरो हो जाएगा, और टी को डिवाइड कर दिया उधर, तो इट इज डी एस इज ग्रेटर देन इक्वल टू जीरो। टी इज नॉट जीरो, टी इज नॉट जीरो, टी इज इन केल्विन। It's a system temperature, it is not 0 Kelvin. It can be any temperature. TDS is greater than or equal to 0 आएगा यहाँ से। Right? So if you take T on the other side, again it is ds is greater than or equal to 0. T is not 0. ठीक है? Any question on that?
No sir.
Okay. So हो गया notes किस सबका?
Yes,
Yes
sir.
sir.
Okay. So entropy is constant. See, in this case, always you'll see equal to and greater than or equal to or less than or equal to. So when you say equality, equality is always for a reversible process. That means ds is equal to 0 for a reversible process, and ds is greater than 0 for an irreversible or a spontaneous process. ऐसे बोलते हैं ना, entropy of the universe is always increasing because all the processes are irreversible. There is no reversible process in reality. Okay, so that's why we have this two system, equal to or greater than. Equal is for reversible process and greater is for irreversible process. Okay, since an irreversible process leads a system to an equilibrium state, irreversible process में क्या होता है, change होता है, right? But it will reach a state of equilibrium when there are no net forces acting. Entropy is maximum at equilibrium when no further spontaneous process is possible. बढ़ते जाएगा, बढ़ते जाएगा, बढ़ते जाएगा, and then there is no change, equilibrium रहेगा. Okay, ठीक है? Any questions on this? So there are two or three, I think three systems will derive, three conditions will derive for criteria of equilibrium for different conditions. First is for constant U and constant V. Then we'll see others. ठीक है? Can I move forward? Any questions so far? ठीक है. If there are no questions, let's take the second condition: constant temperature and constant volume system. So Helmholtz free energy is A is equal to U minus Ts, and we know that U is equal to, from here we know that U is equal to A plus Ts. इधर लेके आए तो, so du will be equal to dA plus Tds plus sgt, taking total derivative of our equation. Okay, and first and second law combined is du is less than or equal to Tds minus Pdv. We have seen this before. So if you substitute in this equation, what you'll get is dA plus Tds plus sgt. Right hand side वाला पहले लिखा है मैंने, and that is less than or equal to Tds minus Pdv, because du is less than or equal to this equation right hand side. तो यहाँ पर सिर्फ ये उल्टा नहीं इधर किया मैंने, इसको यहाँ सब्स्टिट्यूट किया, dA का वैल्यू यहाँ सब्स्टिट्यूट किया मैंने. What you get is dA plus Tds plus sgt is less than or equal to Tds minus Pdv, and Tds cancels out on both the sides. What you get is dA is less than or equal to minus Pdv, and if you bring this here, minus sgt. So for constant temperature, dt is equal to 0, and constant volume, dV equal to 0. Therefore dA for constant temperature and constant volume system is less than or equal to 0. So equation 14 is a condition for constant temperature and constant volume system. Any questions on equation 14?
No, sir.
Okay, so what this means is spontaneous process at constant temperature and volume is accompanied by decrease in work function, right? For irreversible process. Less is for irreversible, equal is for reversible, as usual. Right? Or remains unchanged for reversible process. For reversible, it is 0. So in equilibrium at constant temperature and volume, moles free energy or work is minimum. Less than 0 बोला तो minimum होने वाला है. So this is the second criteria of equilibrium if the system is at constant temperature and constant volume. First one is constant U, internal energy, and constant V. Second is constant temperature and constant volume. Any questions, doubts on this derivation? Okay, notes? Somebody has to give me a signal.
Yes, sir.
Okay. So let's see the third condition. Third type of system is constant pressure and constant temperature. And this is most relevant for us as chemical engineers because most of the, or almost all you can say, systems in chemical engineering are operated at constant temperature and constant pressure. Constant volume, constant temperature systems are very, very rare. Constant U and constant V is also very, very rare. पहला तो आएगा ही नहीं, but we have derived it for different systems. But we have to focus mainly on constant pressure and constant temperature. That is what we will see in our thermostat studies for phase equilibria and reaction also. So we start with Gibbs free energy. G is equal to H minus Ts. And we know that H is equal to U plus PV. So if you substitute in this, what we'll get is G is equal to U plus PV minus Ts. Then we take a total derivative. You'll get dg equal to du plus pdv plus vdp minus tds minus sdt. So if you bring it on the other side, du is equal to dg minus pdv minus vdp plus tds plus sdt. And we know that equation for first and second law is du is less than or equal to tds minus pdv. Right? So if you combine equations 15 and 16, let me just substituting this here. What we get is dg minus pdv minus vdp plus tds plus sdt is less than or equal to tds minus pdv. And TDS cancels out on both the sides. Minus pdv and minus pdv cancels out on both the sides. So what we will get is dg is less than or equal to, we are bringing this on this side, vdp minus sdt. And for constant pressure system, dp is equal to 0. And for constant temperature, dt is equal to 0. So what you'll get is dg for constant temperature and pressure systems is less than or equal to 0. Any questions on equation 17? Okay, notes?
Yes, sir.
Okay. So free energy decreases or remains unchanged depending on whether the process is spontaneous, If it is spontaneous or irreversible, it is decreasing, that means it is less than 0, or if it is reversible, it is equal to 0. So in equilibrium at constant temperature and pressure, gives energy is, or G is minimum. That is why we had seen some time back, for any condition or any process at constant pressure and temperature, delta G is less than 0 unachieved condition for feasibility of a process, whether it is phase equilibrium or reaction. ये condition हम use करते हैं because most of the systems are at constant temperature and constant pressure. Okay, so since most reactions, unit processes and unit operations are carried out at constant temperature and pressure, equation 70 is commonly used criteria of thermodynamic equilibrium for phase equilibrium as well as reactions. Any questions on equation 70 and 17, its derivation? Generally एग्जाम में आता है राइट शॉर्ट नोट और डिस्क्राइब डिराइव क्राइटेरिया ऑफ इक्विलिब्रियम, तो ये तीनों डिराइव करना पड़ेगा. डिराइव ऑल थ्री, इट्स नॉट जस्ट वन, इट इज डेरिवेशन ऑफ ऑल थ्री.
सर उससे हम प्रेडिक्ट क्या कर सकते हैं कि ये क्राइटेरिया ऑफ थर्मोडायनेमिक इक्विलिब्रियम?
We'll see later how to apply it. See, ultimately क्या होता है, suppose I propose a new system, or I want to do a phase equilibrium study, or I want to do separation, distillation. So if delta G is not less than 0, it is not feasible. Process हो ही नहीं सकता वो. और बहुत बार ऐसा होता है, we'll see later in reactions at room temperature, if we calculate delta G is greater than 0. So it is not feasible. But if I do the same reaction at say higher temperature, at say 500 degrees centigrade, delta G becomes less than 0. So the same process, same reaction is not feasible at a certain temperature, low temperature. At higher temperature, delta G becomes less than 0, and that is feasible, it is possible. That is why many reactions are carried out at higher temperature. They may not be feasible at low temperature, or what you call, reaction may be very slow. There may be many conditions. One could be that reaction is not feasible at low temperature. The other condition but could be that okay, reaction is feasible, but the reaction is so slow that it will take long time. That's why we increase the temperature. और अपन ने देखा है कि what is the effect of temperature on rate constant. देखा कि नहीं? RNS equation देखा था ना PC में?
Yes, sir.
Right? So for every 10 degrees centigrade increase in temperature, what happens to K? Rate constant क्या होता है? It becomes double. So that is why we increase the temperature, because we want to conduct the reaction at faster rate. ठीक है? Any other questions? Okay. So we can say dg equal to 0 at constant temperature pressure as general criterion of equilibrium. इतना होना चाहिए कम से कम. Less than 0 हुआ तो अच्छी बात है, 0 होना ही चाहिए. Now in order to apply this condition, we need equations for dg. We need to find out dg, right? अगर यहाँ पर टेस्ट करना है किसी रिएक्शन के लिए या फेज इक्विलिब्रियम के लिए, तो we need to find the value of G, or change in Gibbs free energy, as a function of composition, right? So this and mass conservation equation provide solution to phase equilibrium problem. We'll see कैसे use करते हैं हम ये conditions. That's what we are going to do, different derivations, and then we'll actually apply to phase equilibrium. This is all groundwork, base foundation for actually doing the vapor liquid equilibrium or liquid equilibrium. ठीक है, any questions so far? Okay, so let's see second one. So that was the criteria of equilibrium. Now next is criteria of stability. The system should be stable. For any system to exist, it has to be stable also. Equilibrium तो है, but stability is also important. If it is unstable, you'll not be able to handle it or use it. ठीक है? So criterion of equilibrium, we have seen dg as a function of constant temperature and pressure is less than or equal to 0. Now we can use the same thing to define the criterion of stability for a binary system. So when two liquids are mixed, the mixture should have lower free energy. That means dg is what? When I go from state 1 to state 2, that is dg, right? If I go from state 1 to state 2, what is the value of free energy? If it is g1 and g2, so dg is nothing but g2 minus g1. If I'm going from state 1 to state 2, dg is g2 minus g1, right? So the mixture should have lower free energy at same temperature and pressure. So when I'm going from 1 to 2, if it is negative, that means it should be lower than the previous state. Okay, any questions on this? Okay, because the mixed state is an equilibrium state or stable state compared with unmixed state, right? So dg is less than or equal to 0 dekha humne. For reversible, irreversible, that's right. Dg is equal to g of mixture. If I am taking two components, suppose I take ethanol and water or any two systems and mix them together. So the mixture, is it going to be stable or not? That's going to be based on other what we derive. So dg is nothing but g of the mixture after mixing minus summation of g of the pure components. Okay? And this is less than 0 for reversible process. So molar free energy of the mixture, that means if I take it here, is less than the sum of molar free energy of components, pure components, right? Or rather, ये नहीं. I take this on this side. Okay. So G of the mixture is less than the sum of the free energies of the components, pure components. That is G minus summation of xi gi is less than 0, or energy of mixing, energy change on mixing, or free energy change on mixing is less than 0. Okay, that's what we already seen condition for equilibrium. Now let us see what is the stability condition. Okay, so if you're looking at, if you plot delta G versus mole fraction, y-axis is delta G and x-axis is mole fraction of component in mixture, and you're taking a binary system, right? So what you can get two types of curves. One is this type of curve, smooth curve, which is going from one end to other. This is, see, delta G is all less than 0, right? We can see this here. This is 0. So delta G is negative.
Sir, repeat.
They have plotted this. If you see the x-axis, 0 to 1 है ये, 0 to 1 है, right? और ये y-axis is 0 से below. So this is negative. So this is all feasible because delta G is negative. But now we have to see whether the systems are stable or not. So there are two types of curve which you can get depending on the systems. One is this type of curve, which is a smooth curve. You're getting this, sorry. This type of curve, which is green curve, which is very smooth curve at the bottom below the zero line. And the other one is this red curve, which is moving like this. It's going, turning like this and turning like this, right? Okay. So if you look at curve 1, and it is observed that curve 1 is a miscible system over the entire concentration range. It's observation, right? If it makes two systems like ethanol water, it is miscible in entire concentration range, right? So if you take this point A here and point B here and draw a line connecting AB, so delta G and composition of two phases when solutions represented by points A and B are mixed together. So when you mix together, say suppose you take one composition, this one, XA mole fraction of component 1 and XP mole fraction of component 1 in the second solution, and we mix the two. Suppose I take ethanol water, suppose I say 10% ethanol water and 90% ethanol water, right? So this is 10%, suppose I say, and this is say 0.9. And if I mix these two solutions together, the delta G will be somewhere on this line connecting A and B. And the composition will depend on the ratio of A and B. क्या बोलते हैं अपना lever arm principle. So it will depend on what is the composition of A and B, or rather ratio of A and B. तो कितना वॉल्यूम ऑफ ए लिया है हमने, ये जो सॉल्यूशन है, कितना वॉल्यूम ऑफ बी सॉल्यूशन लिया, डिपेंडिंग ऑन दैट द कंपोजिशन ऑफ द मिक्सचर विल बी, right? So if I am taking composition of mixture, this one is the mixture composition. It will depend on how much is the volume of this mixture and how much is the volume of this mixture, and that will be always fall on somewhere on this line. There is a lever arm principle. ये आपने मैथ में पढ़ा होगा. And line AB is above the solid curve AB. Solid curve is this one, जो नीचे से आ रहा ग्रीन वाला, इसके ऊपर ही है. देखो फ्री एनर्जी ऑफ द मिक्सचर, दिस इज फ्री एनर्जी ऑफ द मिक्सचर, जो लाइन है AB इज ऑलवेज गोइंग टू बी लेस देन फ्री एनर्जी ऑफ A एंड B. ये नीचे वाला जो है A एंड B का है. सो मिक्सचर का रहेगा यहाँ पर रहेगा, सपोज इट इज हियर, so it is less than this value. Anyway, it is less than this value. It is less than this value. So delta G is negative. समझ में आया? Any questions on this?
सर वो लाइन का रिपीट कर दो ना, वो ए और बी.
कलर क्यों चला? कलर नहीं दिख रहा है ना अभी? ग्राफ का कलर नहीं दिख रहा है. आई डिड समथिंग. What was it? I did. Okay. So if I'm taking this curve, right? And I take 2 points on this curve, this A and this point B, right? ये composition है A का, ये composition है B का. Right? And I mix different volumes. Suppose I mix 40 ml of A and say 50 ml of B. So depending on how much volume I mix of A and how much volume I mix of B, right? For 50-50 लिया, suppose I take 50 ml of A and 50 ml of B. तो हमारा composition क्या हो जाएगा? हाफ हो जाएगा, right? 0.1 और 0.9 का, it will become half. But if I take say 100 ml of A and 50 ml of B, the composition will be different. Depending on how much volume I take of solution A and how much volume I take of solution B, the composition will change of the mixture. And that's what this line shows. This line जो connecting है A B को, this line is essentially a composition of the mixture after mixing A and B in different proportions. And that proportion is given by this A and B. Lever-arm principle, right? A is actually B and A रहना चाहिए. B and A. So B is for this, A is for this. ये उल्टा है. लीवर आर्म में उल्टा ही होता है कभी भी. ए कंपोजिशन का वॉल्यूम यहाँ आएगा इस साइड में, और बी वाले कंपोजिशन का वॉल्यूम यहाँ पर आएगा. So depending on this ratio of A and B, volumes of A and B, the composition of M will change. But this M is always going to be above this curve. यहाँ पर जो line है, it is above this curve. So delta G of mixing A and B is always going to be negative because it is above that. Suppose this is say, suppose my mixture का जो है ये यहाँ पर है composition, तो यहाँ पर जो रहेगा, suppose this is -50 and this is say -30, because this is above, right? और ये नेगेटिव है, this is negative. So this is -50, this is -30. तो मिक्सचर का क्या हो जाएगा? डेल्टा जी क्या हो जाएगा? -30, सॉरी, -30 माइनस ऑफ -50, पॉजिटिव हो गया क्या? नहीं -50 नहीं होगा, सॉरी. यू टेक समेशन ऑफ xi gi ना, यहाँ का जो रहेगा और यहाँ का जो रहेगा वो लेके करना पड़ेगा. सो इट विल ऑलवेज बी नेगेटिव बिकॉज दिस अबाउ दिस का कम हो रहा है ना, ये विल ऑलवेज बी नेगेटिव. डेल्टा जी विल ऑलवेज नेगेटिव फॉर दिस सिस्टम. Just by looking at the curve, you can say that okay, it will be negative because it is above that this curve of delta G for different composition of component A.
Sir, the curve is for pure component.
Not for pure component, it is for different. ये जो नीचे का curve है, ये जो curve था, ये वाला, ये जो curve है, ये curve is for different compositions, right? Point x equal to 0.1 पर ये वैल्यू है, x equal to 0.9 पर ये वैल्यू है, x equal to 0.5 पर ये वैल्यू है, right? So it is for different compositions. Suppose it is component A and 1 and 2. So if I plot x1 here, so x1 is changing from 0 to 1, right? ये 0 है, ये 1 है, यहाँ पर 0.1 है, यहाँ पर 0.9 है, यहाँ 0.95 है, right? So this curve is actually for different compositions of the solution क्या delta G है. But if I take two solutions A and B and I mix them together, जैसे हम सपोज आई टेक चाय बनाते समय हम चाय पानी लेते हैं, उसमें मिल्क डालते हैं, राइट? So milk has certain composition. It has some proteins, has some water, something, right? If I mix it with water, तो composition change हो जाएगा mixture का, right? So same thing will happen here. Suppose I take two solutions and mix them together. What will be the composition of the resulting solution? That's what this line AB is going to show. And that line AB is always above the curve because this is concave, concave upwards. तो ये लाइन ऊपर ही रहेगा और that is why delta G is always going to be negative for this. ठीक है? Any questions on this? So this system is stable. It is observed that जितना भी मिक्स किया हमने, कैसा मिक्स किया, it is always going to be stable system. Whereas the नीचे वाला कर्व जो हमने देखा है, if you see this curve which is going like this, right? ये नीचे वाला कर्व जो है ना, ये यहाँ से आ रहा है, यहाँ जा रहा है, यहाँ आ रहा है. This is going to be unstable because if I join these 2 points, right? तो मिक्सचर का डेल्टा जी रहने वाला यहाँ पर रहने वाला, which is below this thing, right? यहाँ पर ऊपर था, यहाँ पर नीचे में है, right? So if I take any two compositions from say between this and this and mix them together, delta G is going to be यहाँ पर और ज़्यादा होने वाला है, नेगेटिव होने वाला है. So यहाँ पर कम नेगेटिव, यहाँ पर ज़्यादा नेगेटिव. So delta G is going to be positive for this kind of system. If I mix anywhere between, यहाँ पर बाकी जगह पे ठीक है, यहाँ पर everywhere it is going to be same, but in this region it is going to be unstable because this curve is bending like this and mixture का जो रहेगा delta G नीचे आने वाला है इसके curve के, not above the curve. Difference समझ में आया? In first case, the mixture delta G is above the curve, it's going to result in delta G negative. In the second case, mixture delta G is below the curve, that's going to result in delta G being positive, and that's going to lead to instability. Any questions, doubts on this? Just by looking at the curve, you can say कि ये stable होगा या unstable होगा because जो curve का properties है उसके हिसाब से delta G is going to be negative in one case and it's going to be positive in another case. कोई डाउट है, किसी को क्वेश्चन है? यस, नो, नहीं समझा, समझा? दीक्षिता समझा क्या?
Yes, sir.
आवाज नहीं आ रहा है.
समझा सर.
किसी को डाउट है इस पे? इट्स नॉट इजी कॉन्सेप्ट, थोड़ा डिफिकल्ट है. So just you have to understand that when we join, if it is smooth curve and we will take any 2 points, the line joining those 2 points is above the curve, which indicates that this is going to be miscible system. And if there is a, what you call, discontinuity or some kind of a change in shape of the system like this, तो उसमें क्या होने वाला, line joining these 2 points is going to be below the curve and that's going to lead to positive delta G, which is indication of instability. And this is basically coming from mathematics. We'll see that. So free energy of mixture in miscible state is minimum and mixture exists as homogeneous phase. Curve 2 is not representing a homogeneous phase, it forms heterogeneous phases. If we take oil and water, right? मिक्स होता है कि ऑयल एंड वाटर? नहीं होता, राइट? तो I mean that's an example, but यहाँ पर क्या है, it could be some other system. I'm not giving other examples, but oil and water is example कि कभी मिक्स नहीं होता, तो उसमें ऐसा डेल्टा जी will be below the curve for the mixture. So लाइन एम एन ये जो था, ये जो हमने दिया लाइन एम एन है, ये we are taking this as m and n. So line Mn represents free energy of two-phase mixture obtained when two binary mixtures M and M are mixed together, heterogeneous. Line Mn is below solid curve, and that means it is below the homogeneous phase. जो ऊपर का dotted solid curve है, this represents homogeneous thing, but if you mix them together, it becomes heterogeneous. So any point on the line Mn represents G and composition, delta G and composition of two phases when two solutions are mixed M and M in different proportions. In this case, there is a decrease in free energy when move from solid to dotted line. So dotted solid से dotted line गया तो delta G negative हो रहा है, right? कम हो रहा है, sorry. Because that delta G is always negative, right? ये जो हमने plot किया है, negative plot किया है, यहाँ से जो इधर आ रहा है तो और कम होते जा रहा है. यहाँ पर कम नेगेटिव में कम नेगेटिव ज़्यादा हो रहा है, जिससे -50, तो दिस विल बी -70. यहाँ पर क्या था, -30 था और -50 था, तो इट वॉज not reducing, it was actually increasing. So in this case, the system will become stable when it moves from homogeneous to heterogeneous state. So homogeneous state it is unstable, and heterogeneous state it will become stable. It will become like it can exist. It, बाकी इस homogeneous phase में it cannot exist. Oil and water mix किया, कितना mix करो, they cannot exist as a solution. Separate हो ही जाएगा oil and water. So that is a stable system, oil and water system. If you mix it together, oil and water is not a stable system. Settle हो जाएगा बाद में. So for mixtures of composition between point M and M देखा हमने, equilibrium exists for two immiscible phases. दो फेज हो जाएगा, सेपरेट हो जाएगा. ठीक है, any questions on this? Okay, so from these curves AB and MN, this is mathematics basically. Second derivative of delta G with respect to x1 is always positive for AB, stable system. And second derivative of delta G with respect to x1 becomes 0 or negative when Mn for Mn when phase separation occurs. तो जब ये होता है, that means when you have a system like this, delta G का second derivative is always positive. When you have a system like this, here second derivative of delta G is 0 or negative. And how is that? If you take delta G, this is delta G, right? Y is delta G, and this is x. तो यहाँ पर हमने slope लिया यहाँ पर, suppose I take slope at any point. What is that? Slope is delta G by d delta G by dx1. ठीक है? So if I take slope, it is d delta G by dx1, and second, if I plot d delta G by dx1 versus x1, right? If I take the slope and plot, यहाँ पर क्या है, slope क्या है? What is the slope of this curve and this curve एंड दिस कर्व, इसका कितना आएगा, पॉजिटिव आएगा नेगेटिव आएगा? व्हाट इज द स्लोप ऑफ दिस, पॉजिटिव नेगेटिव? स्लोप कैसे लेते हैं?
सर नेगेटिव आएगा ना?
राइट, नेगेटिव आएगा। इस यहाँ पर ये जो पॉइंट रहेगा, इन्फ्लेक्शन पॉइंट जो रहेगा, राइट, जहाँ जहाँ से टर्न हो रहा है वहाँ पर क्या आएगा स्लोप?
0।
0। और यहाँ पर क्या आएगा? पॉजिटिव आएगा, राइट। सो इफ यू प्लॉट दिस, 0 लिया हमने, राइट, तो इफ इट विल बी लाइक समथिंग लाइक, आई डोंट नो कैसा आएगा, बट इट विल बी गोइंग फ्रॉम हियर टू हियर, राइट, बराबर। पहले नेगेटिव है, बाद में 0 हो जाएगा, बाद में पॉजिटिव हो जाएगा। ठीक है, इट कुड बी समथिंग लाइक
Yes.
दिस, राइट, समथिंग लाइक दिस। नेगेटिव है, फिर 0 हो जाएगा, फिर पॉजिटिव हो जाएगा। तो दिस इज फर्स्ट डेरिवेटिव। इसका अभी सेकंड डेरिवेटिव लिया हमने, सपोज आई टेक डेरिवेटिव ऑफ दिस, राइट, इसका डेरिवेटिव जितना भी लिया मैंने, इट इज ऑलवेज गोइंग टू बी पॉजिटिव, बराबर, बिकॉज दिस कर्व इज लाइक दिस। तो यहाँ पर कहीं भी टेंजेंट लिया मैंने, तो इट इज ऑलवेज गोइंग टू बी पॉजिटिव। समझ में आया? सेकंड डेरिवेटिव, बिकॉज दिस एंगल इज ऑलवेज लेस देन 90 डिग्रीज, राइट, जितना टेंजेंट रहेगा उसका टेंजेंट इज एंगल इज ऑलवेज लेस देन 90 डिग्रीज, ये जो एंगल है। सो दिस इज ऑलवेज गोइंग टू बी डी स्क्वायर delta g by dx1 square is always going to be positive. That's what we are saying here, right? For a stable system. समझ में आया पहला वाला?
Yes, sir.
Okay. So if I take the second one, if I take the second one, which is like this, right? And if I plot, suppose I say tangent यहाँ लिया और यहाँ लिया, right? अभी delta g d delta g by dx1 क्या हो जाएगा? This one is यहाँ पर लिया 0 हो जाएगा, यहाँ पर लिया पॉजिटिव हो जाएगा, it's going to be 0 here, it will be 0 here, it will be positive here, it will be negative here, right? Okay, so what we'll get is 0 somewhere, then positive, then 0, then negative, right? ठीक है, समझ में आया? दिस इज नेगेटिव, राइट, सो नेगेटिव से आया, फिर 0 हुआ, फिर पॉजिटिव हुआ, फिर 0 हुआ, फिर नेगेटिव हुआ, so it will be something like this. समझ में आया? डी डेल्टा जी बाई डी एक्स वन सेकेंड कर्व के लिए, बिकॉज इज चेंजिंग शेप, राइट, ऊपर
Yes.
जाके फिर नीचे आ रहा है, अंडरस्टूड? So initially it is, here it is positive, then it is 0, then it is, so it's sorry, first it is negative, then it is 0, then it is positive, then it is 0, then it is negative, right? So negative, 0, positive, 0, sorry, 0 यहाँ पर आया, फिर यहाँ पर फिर नेगेटिव आया, so it is changing, going up and down, it's like a sine wave. So if I take derivative of this now at different points, So what will happen is if I plot d square delta g by dx1 square, right? So ये पॉजिटिव है, राइट? फिर जीरो आएगा, पॉजिटिव है, फिर जीरो आएगा, फिर नेगेटिव आएगा, फिर जीरो आएगा. सो इट इज कीप चेंजिंग, राइट? समझ रहे?
सर स्क्वायर का एक बार रिपीट कर दीजिए ना, सेकेंड डेरिवेटिव.
ओके, सेकेंड डेरिवेटिव ये जो लिया हमने यहाँ पर, जो ये जो कर लिया, राइट? लुक एट दिस कर्व. इस रीजन में यहाँ पर ज़ीरो है, पॉजिटिव है, ज़ीरो है, नेगेटिव है, राइट? तो इफ यू प्लॉट दिस, इट इज ज़ीरो, पॉजिटिव, फिर ज़ीरो एंड नेगेटिव, राइट? तो ये कर आएगा. ठीक है. एंड इसका भी अगर डेरिवेटिव लिया हमने यहाँ पर और यहाँ पर और यहाँ पर, तो व्हाट विल गेट इज समथिंग लाइक दिस, और दिस पोर्शन. सो इट विल बी इधर नेगेटिव और ज़ीरो, सेकेंड डेरिवेटिव. ये बाकी पोर्शन पॉजिटिव रहेगा, ये जो पोर्शन है ये पोर्शन पॉजिटिव रहेगा. बाकी ये पोर्शन जो है जहाँ इंस्टेबिलिटी है, यहाँ पर वो इट विल बी ज़ीरो और नेगेटिव. अब खुद करके देखो, you can draw yourself and see कैसे shape change हो रहा है. Only in this portion, only in this portion, ये पोर्शन जो है ये अनस्टेबल पोर्शन में ही ये ऐसा आएगा, इट विल बी इधर ज़ीरो और नेगेटिव. एंड विच इज एन इंडिकेशन ऑफ इंस्टेबिलिटी. आई वुड से दैट यू ड्रॉ इट योरसेल्फ एंड सी टेंजेंट निकाल के कैसे चेंज हो रहा है स्लोप, और वो देखो कैसे होगा. ठीक है. अगर डाउट है तो पूछ सकते हैं नेक्स्ट टाइम. एनी डाउट्स, क्वेश्चंस अभी तो पूछना है कुछ? So criteria of stability is free energy change on mixing. First derivative and second derivative are continuous functions of concentration. ये जो है, when you talk about this one, this is a continuous function. This indicates this is a continuous function of concentration, right? And instability में discontinuous function है, ऊपर नीचे जा रहा है, ये जो देखा था हमने. This is not continuous function. Okay? So what we say is d square delta g by dx1 is greater than 0, dx1 square is greater than 0 for stable liquid phase, and it is less than or equal to 0 for unstable liquid phases. You have to actually draw and see. खुद ड्रॉ करके देखोगे तो आपको बेटर समझ में आ जाएगा कैसे होता है. So that will be homework assignment for you. See it for yourself, draw it and see. ठीक है. Any questions so far? No questions? समझ में आ रहा है कि नहीं आ रहा है?
यस सर.
समझ रहा है? ये थोड़ा डिफिकल्ट है बिकॉज विजुअलाइज करना डिफिकल्ट होता है ये. सो यू हैव टू एक्चुअली ड्रॉ द कर्व्स डेल्टा जी वाई वर्सेस x1, स्लोप लेने का वो कर्व कहाँ चेंज होता है, then see what is whether it's positive or negative, then again draw delta d delta g by delta dx1, फिर उसका स्लोप निकालो, देखो कैसे चेंज हो रहा है, एंड देन यू नो डी स्क्वायर डेल्टा जी बाय डेल्टा डी एक्स वन स्क्वायर पॉजिटिव है कि नेगेटिव है कि जीरो है, तो ड्रॉ करके देखेंगे तो अच्छे से समझ में आएगा। जो मैंने बताया वही करने का है, बट एक्चुअली इफ यू डू इट इट विल बी फॉर्म, कॉन्सेप्ट फिक्स हो जाएगा। ठीक है, एनी क्वेश्चंस, एनी कमेंट्स? अभी आज नोट्स ले सकते थे, वाज इट टू फास्ट और वाज इट ओके?
ओके सर।
देवेंद्र, आर यू एबल टू टेक नोट्स?
यस सर।
ओके, अगर लगता है फास्ट है तो आई कैन स्लो डाउन ऑल्सो, ऐसा कुछ नहीं है, यू जस्ट हैव टू गिव मी फीडबैक, इस बार थोड़ा स्लो करो या रुक जाओ थोड़ा। ठीक है, सो आई विल स्टॉप द रिकॉर्डिंग।